This video is about solving systems of linear inequalities. So in the last lecture video, we looked at how to graph linear inequalities, and now we're going to look at how to solve a system of linear inequalities. So we want to graph the solution to the following system of linear inequalities. We're given two inequalities. That's what makes it a system, is that there's more than one. Our first inequality is 2x is less than or equal to y. So again, just like we did before, we want to graph the equation 2x equals y. Okay, so the slope of this line is 2. And we want to think of that as a fraction, 2 over 1, and its y-intercept is 0. So we have the y-intercept at 0, 0, and then our slope is 2, so we want to go up 2 and to the right 2, and up 2 and to the right 2. That will get you some points. And we graphed it with a solid line because it has the equal sign in it. Other line is x plus y is greater than or equal to 2. And I'm going to graph that one in red. And so this one is in standard form, so doing the intercepts will be the easiest. The x-intercept means y is equal to 0. If y is equal to 0, we get x equals 2. And sorry, this should be the equation, not the inequality. And then the y-intercept, we set x equal to 0, and that gives us y equals 2. So we have the 2 points, 2, 0, and 0, 2. And again, this one gets graphed with a solid line because it has the equal sign in it. So now I need to do some testing. I need to figure out where the solution is for this system. And so you want to pick some point that's not on either one of our lines. And let's see, where would an easy point be? Right here. We'll pick this point, negative 2, 0. And so if we plug negative 2, 0 into this first inequality, we would have 2 times negative 2 is less than or equal to 0. So that would be negative 4 is less than or equal to 0, which is true. And so for the black line, this was the line that we graphed in black, and we graphed this one in red. So we just did the test in the black line, and we got a true statement. So we want to shade the same side of the line as where the x is for the black line. So now we want to test the point negative 2, 0 in our other equation. So replace the x with a negative 2 plus a 0 for the y. Is this greater than or equal to 2? And negative 2 is not greater than or equal to 2, and so that gave us a false statement. So for the red line, we want to shade the side where we didn't put the x. So the x is right here, so we have to shade this side. And so the part that we shaded twice is our solution area. So I'll just go over that with green. So this is the part that got shaded twice, and so that is our solution, that area in there. Our next example, we have x minus y is greater than 3, so we want to graph x minus y is equal to 3. This is going to be graphed as a dashed line because there's no equal sign in our original. And it's set up nicely for intercepts. So we'll do the x-intercept. And that means y is equal to 0. So if y is equal to 0, we'll get x equals 3. So that's the point 3, 0. And then we'll do our y-intercept. That means x is equal to 0. And if x is equal to 0, we get negative y is equal to 3, which means that y has to be equal to negative 3. So that's the point 0, negative 3. It's right there. We're graphing it as a dashed line because there's no equal sign. Oops, that's 0, negative 3. Okay, and so now in red, we'll graph the other line. And so we want to graph y equals 2, and we're going to graph it as a dashed line because there's no equal sign. That's a horizontal line. And the point that I'll test is 0, 0 because it's not on our line. If I plug 0, 0 back up into this original, we get 0 is greater than 3, which is false. And so I want to shade the opposite side of the line, so that would be over here. And this is just a horizontal line, so it's everything below the line that we graphed because it's y is less than 2. So it would be everything under here. So the solution then is the part that we shaded twice, and so that's everything down below this part right here. All of this that I'm shading green is our solution area. And one thing that we haven't been doing, and that we should, is to find this place where the two intersect. And for this one, you can just get it from the graph. So this point on our graph is 2, 3, so it's at 5, 2. And if they intersect somewhere nice, then you can just do that, get it right from the graph. But also, right on this line, y is equal to 2, and you could replace this y with a 2, so that would be x minus 2 equals 3, and then add 2 to both sides, and that would give you the y equals 5. And let's go back up and take a look at the first problem that we had. We can also do a little substitution here. So this point, this intersection is not someplace super nice, but this first one just says y equals 2x. So you can take this 2x and plug it in for y right here. And that gives you x plus 2x equals 2. So 3x equals 2. And then divide both sides by 3, gives you x equals 2/3. And then you can take this 2/3 and plug it into this x. So that would be y equals 2 times 2/3, or y equals 4/3. So this point, and I'll write it down here, is the point x equals 2/3 and y equals 4/3. And that makes sense. X is not quite 1, and y is just above 1. So that point that we found is actually makes sense. So if you can get this point just from reading it off the graph, that's fine. Otherwise, you can do this substitution method. And this next one, so we have x is greater than or equal to 3 and y is less than 2. So we want to graph x equals 3, and let me just change this back to black. So x equals 3 is a vertical line, and so we don't need to plot any points. We're going to graph it as a solid line because it has the equal sign. And the inequality says x is greater than 3, so it's everything to the right of the line. We also want to graph y equals 2. This one's going to get graphed as a dashed line because there's no equal sign in my original inequality. And it's less than 2, so it's everything down below. So the solution I'll put in red there since I haven't used red yet, and it's this little lower rectangular area right here. And this intersection point you can just get from the graph. It's 3, 2 is the point. So whenever you can just get that intersection point from the graph, you can go ahead and do that. And our last example here, 3x is greater than negative 6 and x plus y is less than or equal to negative 2. So first we want to graph 3x is greater than negative 6, and if we divide both sides of this, we should do an equal sign in there. Divide both sides by 3, we really just have a vertical line here. X equals negative 2. There's no equal sign, so we graph it as a dashed line. And it's greater than, so we want everything to the right. And then we want to graph x plus y is keep an equal sign in there, equals negative 2. And so we're going to do this finding intercepts. For the x-intercept, y is equal to 0. If you replace y with 0, you get x equals negative 2. So that's point negative 2, 0. And for the y-intercept, we want to let x be equal to 0, and that gives you y equals negative 2. So that's a point 0, negative 2. And this gets graphed as a solid line. And so we have our intersection point already. It's 0, negative 2, 0. And now we just need to figure out what side of the red line we need to shade there. So we're going to test 0, 0 would be the easiest point. And so if I plug 0, 0 back up into my original inequality, I get 0 is less than or equal to negative 2, which is false. So we shade the opposite side of the line. So that would be this part of the line here. And then our solution is the part that we shaded twice. And so that's this inner part right here. And that's the end of our lecture on graphing or solving systems of linear inequalities. Let me know if you have any questions. Thanks.